So section 7.1 is going to be the introduction section for the functions of several variables. So this time we're going to have multiple independent variables. The first definition we're talking about is functions of two variables. So a function f of two independent variables x and y is a rule that assigns to each order pair x comma y in a given set D, which is the domain, exactly one real number denoted by f of x comma y. So we have function, and then it just got evaluated. I am recording, I'm using a different software. Okay. So here the domain, we are going to assuming the domain of f is a set of all point x comma y for each the expression f of x comma y is defined. No worries. Okay. So the example 1 we have is we suppose f of x comma y equals to 3x squared plus 5y over x minus y. And then we want to find the domain. Okay. So we have a fraction. When we're talking about the fractions, the domain or the part we cannot have is the denominator equal to 0, where the denominator is x minus y. So that means x minus y cannot equal to 0, so x cannot equal to y. So that means we can have any point except x equals to y. Since we have x equal or x cannot equal to y or x equal to y, we see this is a line equation. It's a diagonal line. So we can conclude as the domain is going to be is all points in the xy plane except for the point on the line x equals to y. So it's not going to be any numbers x cannot equal to something. It's going to be all the points on the line x equal to y. For b, we want to compute the function, or we want to evaluate the function at x equal to 1, y equal to -2. So f of 1 -2 will become to 3 times 1 squared plus 5 times y plus 1 minus y. So we got -7/3. Okay, example 2 is very similar to that one. We still want to find a domain and compute f of e squared comma ln of 2. For the first one, the domain, we have x e to the y plus ln of x. X by itself, there is no restrictions. e to the y by itself, there is no restrictions. However, ln of x, ln of x, we do have a restrictions. So for ln of x, we do need to make sure that x has to be greater than 0. So the domain is going to be okay. So the domain is going to consist all the ordered pairs x comma y with x greater than 0. So as long as x greater than 0, y can be anything. For b, we want to compute f of e squared comma ln of 2. That means x equals to e squared and y equal to ln of 2. So f of e squared comma ln of 2 will becomes to x times e to the y plus ln of x. Because e of ln of x is going to be x, and ln of e to the x is also going to be x. So that means e squared times 2 plus 2, which is 2e squared plus 2. We can not only have 2 variables, we can also have 3 variables. Example 3 says, given the function of 3 variables, f of x, comma y, comma z, and we have the equation xy plus xz plus yz, we want to evaluate the function f at -1, 2, and 5. So which means we have x equals to -1, y equals to 2, and z equals to 5. So f of -1, 2, and 5 will becomes to x times y plus x times z plus y times z. Example 4 is a word problem talking about a sports store in St. Louis carries two kinds of tennis racket, the Serena Williams and the Maria Sharapova. The customer demand for each brand depends not only to its price, also the price of the competing brand. So sales figure indicate that if William brand sells for X dollar per racket, and then the Sharapova brand for Y dollars per racket, the demand for William racket will be defined in the function of D1, and then the demand for the Sharapova racket will be defined in the D2 function. And then we want to express the store's total annual revenue from selling those two. So the store's total revenue is going to come from the revenue from the William brand, and then the revenue from the Sharapova's brand. For each revenue, I'm going to using the number of quantities multiplied by the price. So for the Williams brand, the price is going to be William X. And then the demand for William is going to be D1. So X times D1. The revenue for the Sharapova is going to be the Y dollar, the price. Demand is going to be D2. So plug in the D1 and D2. We got X times 300 minus 20X plus 30Y. And Y times 200 plus 40X minus 10Y. Multiply them. And simplify them. We got 300x minus 20x squared plus 70xy plus 200y minus 10y squared. Okay, so that is the function for the total revenue.